Hello, I am Evan Kish,
And I'm Jacob Young.
and I am Evan Kish again, and we are going to be talking about our project for Amazon Athena. We are Group 1. So, what we wanted to do with this project was to understand how Athena makes it easier to analyze and search for data in S3. So we wanted to see how it can interpret S3 and just easily look for stuff. We also wanted to look at how Athena can assist in querying large data sets. So the purpose of our data is to kind of look at the middle section of this image that you're seeing. This is one possible way that we could use our data, would be to take data that we created in S3, EC2, save it into S3, analyze it using Athena, then send it over to QuickSight to show people how the data changes over time. Nice, easy, and automatable, but the example here is just to show how it can be done. So, what were we able to accomplish? We were able to perform a SQL query on a relatively large CSV file rather quickly. We were able to perform the SQL query in 2 to 3 seconds without changing the file. We created the program that allows you to define a SQL query in your CSV file, or a CSV file to run the SQL query on from your S3 bucket, and you can define the SQL query yourself from the command line. And the program also allowed you to run previous queries and some special saved queries. So let you look through your list of previous queries, say, I want to run this one, and run it, or say, hey, these are special saved queries that I run all the time, I want to run this one. Okay, why should you be interested in this? So Athena is extremely useful for repeating queries, as we were just saying. Lets you go back, look at the history of queries that you have said, and say, hey, I want to repeat this one. That way, if you ever run a complex query, it fails, you can just run it again really quickly without having to type out the entire thing again. Athena makes it easy to change data, to see a change in data over time, because, with our program, we saved the CSV that Athena created every time to our S3 so that we could see how the changes see how the results changed from our SQL queries. And then it allows you to perform SQL queries easily on a variety of file types. As we were saying, we performed it on CSV files, but Athena also allows you to perform it on multiple other file types. So, for cloud aspects, what did we use? So, obviously, we used S3 for saving our files to the cloud. We used Athena for querying our files, as we were saying, and we used Boto 3 Python backend to create the data, or to create the program that we were running. Okay, so Athena. What is Athena? For one thing, it's a serverless thing, so it only costs you money when you run the actual query, which is very nice. You don't need it allows you to run queries on something without prepping the data, so without changing the form of the CSV file, you can just run the query. And it lets you query data without loading it to a database, so you don't have to download the CSV, parse it, push it onto a database, then run a SQL query. It just lets you run SQL queries, no matter how complex, on CSV files, which is just so nice and saves you a lot of time and really allows for a lot of automation to just be done. Okay.
All right, so this is Jacob Young talking about our major accomplishments now. So the first thing we're going to answer here is what exists on the cloud exactly? Well, in S3, we have a large data set of our CSV file of the Reddit posts. Like was mentioned earlier, it is 132,000. And as you'll see briefly, there's 13 columns of them. So multiply those two together. It's a lot of data that has to be parsed by someone. But Amazon Athena does it really quickly. It's nice that way. In Athena itself, there's a database and a table with the same columns as that CSV file. The database just being Reddit, and the table being specifically submissions, because we're looking at Reddit submissions. Makes sense. But you can have multiple different tables if you have different types of Reddit data, just so you can put it all together in one database in Athena, but if it's in different buckets in S3. We also have a Python file that interfaces with our Athena implementation when we're not on the AWS site. This can be useful for when someone doesn't have access to it, or they're not, or if AWS is structured to only work on their internet, they have this Python file that can just access it from outside that. So it's nice that way. Moving on to number 2. So what specifically does this Python file and Athena do? Well, they both allow to save a query that the user may want to execute again. If we look at this left picture, I have 4 of them for you here. Let's just say you want to execute the average number of upvotes query again, because you've added, let's say, another image which has another several rows because it's another repost. If you run average upvotes again, it will run it again and average up the new amount of upvotes on all the posts that are in the data set, and the numbers should change. So it's really good that way. It also shows a history of prior executed queries. As you can see on the right, there is part of one of them. One that's succeeded ran in 2.5 seconds. It's pretty nice. With an almost 17 megabyte file of CSV, so a lot of data. And it allows you to download that CSV file if you would like to either your computer or to either your computer, or you could put it somewhere else if you'd like to have another easy access to that CSV itself. When executed from our program, though, specifically, it will save that CSV into another S3 bucket, whereas the Athena dashboard allows you just to download it straight from there. So specifically, though, in the Python file, there are 4 options we have. We have list named queries, which will list the named queries like I have on the left picture again, so you could just see what we have saved. The second option is a return of the results of a query execution. This does not execute it again. It just displays the results to the screen, just in case you want to see what the history of it was, whereas in the history of Athena, it does run the query again if you click it, but this option allows you not to execute again, just to see what it was at a specific point in time when it was run. And then the third option is execute a previous query again. So you can either pick one of the named ones on the left or one from the history list that it appears. And then you will execute it again to see how the data has changed, because it will perform your query, give you a number back, so it's nice that way. And the fourth choice is to create your own SQL query from Python, so you can just type in whatever you want. So select an average number of downvotes from all of them, just to see if the downvotes are greater than the upvotes. And then it will send that query to Athena, queue it, take a few seconds to come back. Then it comes back to your terminal window with the average number of downvotes that exists. It's nice that way. Moving on to number 3, I have 2 pictures for you here. The left picture is a view from Athena itself. It is a picture of the database and the table that we have. It shows our Reddit DB and one table you can have. You can have many tables. As you can see, there's a create table option right there. So you can have a submissions table like we have now. You can also have an images table. If you save CSV, JSON, or another file format of images, you could run queries on that too. So it does allow multiple different data types under one section, so you don't have to worry about organizing data as well. You could just organize them under a database type. Then on the right picture is the query editor. It will show the results of any query you put right at the bottom. For our simple one I've put here, we just selected the count from that, just to demonstrate that it loads in and sees all 132,308 rows. So it's nice that way to just easily and very easily visually tell what's returning. You could do anything you want in that query editor, so it's nice that way. Yeah, all right. So after our major accomplishments, there's future work for you guys. If you have been interested by any of these things we've shown you today, I'd recommend checking out the Amazon Athena documentation, which has both a user guide and an API reference. So the user guide just telling you how how to use Athena to query your data. So it'll explain how the CSV format would work, how you would use it with JSON, how you'd use it with the other file formats it lists. And there's also an API reference, like I've mentioned, that is able to tell you what it returns. So like the dictionary and the list of all the return statements, because it is quite extensive. It does return a lot of data about it to you. So it does help just so you can understand and pull exactly what you need to for it. So I'd recommend checking out the link we have at the bottom here if you want to learn more. moving on to, if we had to do this again, we would probably turn our Python program into a web interface or a more user-friendly interface, because the current version is only useful for experienced terminal users, and some of the formatting in the columns / output is not the nicest to look at. It's hard to tell the length of strings before you return them back. So we would probably just put a user interface which has actual specified sizes, so we know how big everything is, so it looks a little nicer to the user. We'd probably also add a bit more error handling to our execution of queries, because right now, as a student, we don't have high priority for when we put something onto it. It will execute it, but sometimes it waits quite a number of seconds in the queue of queries to execute. But when it does end up executing, we have mentioned, it is really 2 to 3 seconds. Sometimes it takes a minute at max or even longer to actually go through Amazon's system. And like was briefly mentioned at the beginning of the project statement, we'd probably also implement more ways to interact with the data. So right now we have just the two, Amazon S3 and Amazon Athena from this diagram. But if we were to do this again, we'd probably add some interaction with EC2 instances to store information from them on S3 itself, send that S3 data into Amazon Athena, and then send that into Amazon QuickSight in order to see the data over time, more of a real time than just let's run it again now. Let's see it. Whereas QuickSight, we could probably just do like every hour, every like morning, run it again, see what's changed, print something to reflect that, just to show the user a bit better, a bit more ways to interact with it, as opposed to just send that information, send it back, there it is, do with whatever you want. Just have a bit more nicer views of it. But yeah, so other than that, we're going to move on to our demo now. Hello, and welcome to our demo for our Python script that interacts with Amazon Athena. Today we're going to be showing the 4 things we have working in here for commands. We have list named queries that have been saved to Athena, return the results of a previously executed query, execute a previously executed query again, and then we're going to execute our own query. So every aspect I talk about in this demo, I will try my best to highlight on the screen to make sure you can see what I'm talking about. Some of the data can be quite long, so it's kind of hard to interpret, so I'll make sure I do my best so you can see it. So we're going to start with number 1, and we're going to list some commands we have saved already. So let's highlight number 5 here. This one's called less than 100, and the description I've given it is posts that have had less than 100 upvotes. And the query is select the count from reddit.submissions where number of upvotes is less than 100. Simple enough. I'm going to do 5 to clear the screen here. Then I'm going to go with 2, and we're going to return the results of a previously executed query again. We hit 2, it's going to list 50 of them, as you can see 50 down here at the bottom. So we're going to do number 49 here, to select the count from Reddit submissions where the number of upvotes is greater than 10,000. As you can tell, it has succeeded, so it should return some results. So we type in 49 here, hit enter, and it gives us a result of 3,096. So there are 3,096 posts in our data set that have over 10,000 upvotes. It's pretty cool, I like it. I'm going to clear the screen one more time. Now we're going to do number 3, to execute a previously executed query again. So we're going to enter 3, and it's going to give us a choice between a named query and a query from the history. So just because we did something from the history, we're going to look at a named query. So we're going to type in named. It's going to list all the named ones we've given it. So let's do number 2 here, the average upvotes. So it returns the average number of upvotes on all the posts in this data. So it selects the average number of upvotes from reddit.submissions. So we'll do 2, and we'll wait a few seconds for this program to come back to us. And it returns a result of 1,099.994 if we round it up a little bit. So averaging all of the over 130,000 data columns we have, the average number of upvotes on a post is just about 1,100. So reposts get a lot of upvotes apparently. So we're going to hit 5 to clear the screen. And then we're going to do number 4 to execute our own query. So we're going to hit 4. So this is just a reminder, any string that's not the data base or the table is a single quotation mark as opposed to a double. So we're going to do something a little complex and select the average number of upvotes from Reddit.submissions where the score is less than 0. So any post where the score, just to make sure we're understanding here, is when the number of downvotes is greater than the number of upvotes on a post. So we're going to run this query. It's going to take a few seconds to come back to us. And then the result is on a post where the score is negative, so there's more downvotes than upvotes, we get a result of 6.758 or 76. So about not very high amount of upvotes if it's voted negative. Well, so then we're also given the option for the user to, would you like to save this query? So we're going to hit yes. So we're going to enter a name. So we're going to enter upvotes. We're going to enter AVG upvotes for negative score. And then the description is the average amount of upvotes the posts get when they have more downvotes. And then we hit enter. Tells us the query has been saved. Brings us back to the menu. So we'll clear the screen, hit 1, and then we go. There's a number of queries here. Hold on. Number 4 here. Average upvotes for negative score. The average amount of upvotes the posts get when they have more downvotes. So we select the average number of upvotes from Reddit.submissions where score is less than 0. And if we go to 2, the option we did before to return the results of a previously executed query, which lists the query, we should see 50. So it only holds a maximum of 50 things in the history, so we might have to scroll a little bit to find this. So in the 22 and 23 area, where I've highlighted, is the select average number of upvotes from Reddit.submissions where score is less than 0, and then 23 is the same with downvotes, and they both succeeded. So if I do 22, it comes back with that number we saw earlier, 6.758, so 6.76. All right, and that is our program. I hope it was very informative and cool, and you would look into more Amazon Athena. Thank you for watching. Zero to exit. Thank you for using the program.